The last section for vectors, of course, is your applications. We're going to apply basically the concepts that we've learned about vectors and the different properties for vectors into real world situations. So this is when we're looking at like boats traveling or planes and or things like that, okay? So it's pretty much all examples and then basically trying to see, you know, when they ask for certain things, what part of like the properties or the formulas or the things that we've done with vectors so far that will help us answer the respective questions. So learning how to apply the concepts and the properties of vectors to real world situations. So let's take a look at this example. It says position of boat A, T hours after it leaves the harbor is given by R1, which is the parameter T, then 30:15. A second boat B is passing near the harbor. Its position vector at time T is given by vector R2. Okay, it asks how far apart are the boats at the time the first boat leaves the harbor, how fast are these boats traveling, and are the boats in danger of colliding? So you have two boats here. One leaves the harbor and is given by that equation, okay? If you notice, what is the position vector of boat A?
0.
It's 0, 0, right? So the harbor is like the origin of this particular vector, and then it's heading in the direction of 30:15 for however many hours, right? Then you have a second boat that's passing near the harbor. Where does it start? At 55, and then it heads 10:10 in that particular direction for a certain number of hours. So when it asks you for how far apart are the boats at the time the first boat leaves the harbor, what part of the equations are you going to use, and what are you looking for? Like what concept from vectors that we talked about are you going to use? Say it again.
Isn't it just 55 how far?
50 and 5?
Yeah.
That's where R2 is. That's where boat B is.
Don't they start from the origin?
Yeah, that's the other boat.
One of the boats starts at 0, 0. So R1 starts at 0, 0. So this is 0, 0. That's one boat. But then the other boat starts at 50 and 5. So when it asks how far apart are the boats at the time the first boat leaves the harbor, it's basically asking how far apart are they before the first boat starts to go. So you have to basically find the what?
Magnitude?
The magnitude, because magnitude is another word for what?
Length.
Length. It's asking how basically how far apart are they? Length. Length is magnitude. In order to do that, yes, you do need your vector, which is simple in this case because this one's at 0, 0. So your vector is 50 and 5. So then you'll do the magnitude of that vector. And let's use our calculators to get a decimal here. What's the distance?
50.2.
50.2. And we're not giving any, let's just say kilometers for right now. Okay? Usually they give you something, especially when it comes to your word problems. Okay? Questions on that? So anytime it talks about how far apart something is or the distance between two things, you're basically looking for the length. Length is magnitude. Okay? Now when it asks you how fast is these boats traveling, that means you're basically trying to figure out their respective what?
You find the magnitude of the direction?
Yes, and why?
Because that shows you how much they're moving.
Okay.
Yeah.
We are going to need to figure out their magnitudes. How fast, aka their speed. Speed is also magnitude as well. But this time we're not using the position vectors. We're using their direction vectors because that is the path in which they're traveling for a certain period of hours. So for R1, we're going to use the direction vector here. So that's 30 squared plus 15 squared. And then for R2, that's going to be 10 squared plus 10 squared. Go ahead and give me the decimal approximation so we can figure out how fast these boats are traveling each. What's R1?
33.5.
33.5 kilometers per hour. And then what about R2? 14.1 kilometers per hour. Okay, so anytime it talks about speed, we're trying to find the magnitude of their respective direction vectors. Are the boats in danger of colliding if one of the boats does not change course? What concept from our notes deals with the intersection, basically, of two vectors? Okay, we find the intersection by doing what?
Setting both vectors equal to each other. Creating a system of equations.
Right, creating that system. Well, if you notice, both equations have the same parameter, and it is only two-dimensional, so we're really only going to need to solve for one of the equations, and then we'll plug the value of the parameter in for the second equation. So that's 30t equals 50 plus 10t, and then 15t is equal to 5 plus 10t. Since the parameter is the same for both vectors, like I said, we'll only just solve for one, and then we'll plug that parameter into the non-used equation to see if they do indeed collide. How do I know if they collide?
If you plug in t and it equals each other.
And they equal. So let me go ahead and use the bottom one since I have the space there. I'm going to subtract 10t over to get 5t equals 5. So my parameter is equal to 1. I plug 1 back into the first equation because I'm trying to see if they do indeed intersect. This gives me 30. The other side gives me 60. Are they going to collide? No. Because they do not equal each other. And this is an example of an application problem. The position vector of a ship S is 30 kilometers north and 60 kilometers east. The direction vector of buoy B is 20 kilometers north and 45 kilometers east. Okay, don't forget your directional points. At the top, we have north. At the bottom, to the right, and the left. And so don't let it confuse you. Don't let it throw you off. When it says 30 kilometers north and 60 kilometers east, these are the positive directions, where south and west are your negatives. And so for the ship, what's the vector that represents the ship?
60.
Careful. When it's set up in a vector, because this is a two-dimensional one, remember, the first component will tell you your horizontal changes, where the bottom vector shows you your vertical changes. That's all it's like.
60.
So it's 60, 30. Don't let that throw you off. Remember, the top vector tells you how you move left and right. The top component, the bottom component tells you up or down. So north and south are up and down. So that means for the buoy, what's the vector that represents the buoy?
45, 20.
45, 20. Yeah, so be careful with that. Be careful with your directions. So, of course, when I ask you for position of the ship, you want to make sure that you use your directions. Okay? Not your directions. Your compass points. Okay? So it'll be set up in the same fashion. There's going to be some value north or south, some value east or west. But how do I find the position of the ship relative to the buoy?
You subtract.
Say again?
You subtract the buoy from the ship.
I subtract the buoy from the ship?
Yes.
So B minus S?
No. S minus B.
S minus B. There you go. Okay? It says relative to the buoy, so it's really like you're trying to find basically vector BS. Okay, so that's 60, 30 minus 45, 20. And what is that? 15 what?
10.
15, 10. And then, of course, what's the exact distance from the buoy to the ship? Magnitude of
15, 10.
15, 10. Let me go back and fix the answer to A. What you get for the magnitude?
18.0.
So 18.0. So 18.0 kilometers. And I need to go back and fix A because I am trying to find the position of the ship. 15, is that north, south, east, or west?
East.
So I'm going to be 15 kilometers east because it's positive. And remember, in the positive direction, the component at the top, that's left or right, east or west. East is positive. And there's going to be 10 kilometers north for the bottom vector. Questions?
So because they asked, like, for the position, like, after you find the position of it, you have to turn it into the, like, talking when we're talking about east and west, like that.
Because it was given to you in that fashion. So remember I said if the problem gives it to you in adjacent case, your answer should be in adjacent case. One more example, then we'll give a trial of a few on your own. The position of two helicopters, X and Y, at time t seconds is given by the respective formulas. As you can see, the distance is given in meters. You're going to find the speed of the two helicopters. Remember, speed means
Magnitude of the directional vector.
magnitude of the direction vector. So I need to find the magnitude of R1, and I need to find the magnitude of R2. This is a three-dimensional one. It should be. Which one's the direction vector again?
Oh, the one attached to the parameter.
One attached to the parameter. So that's 1 plus a -1 squared plus a 4 squared. And that's going to be a 2 squared plus a 1 squared plus a 9 squared. What was the magnitude of R1? What's that as a decimal?
3.3.
3.3 what? I know, but it was what? So, okay. So, never mind, okay.
It's 16 plus 2.
So, what is it?
4.24.
4.24. So that's 4.24 meters per second. This is times in seconds. And then what about R2? What's the magnitude of R2? 9.27 meters per second. Awesome. Now for B, it says show the two helicopters do not meet. As you guys know already, that means we're looking for the intersection. We're trying to make sure that they do not equal each other, which means we need to set up our equations, yes? Now, even though it may be tempted, especially if you notice that the two equations have the same parameter, always write all three equations. Because in the mark scheme, it will say award A1 or A2 for seeing all three equations. Okay? So make sure you write all three equations, even if you're only going to use one of the equations because of the parameter. This is the same. Okay? Always write all three. So then if I use the first one to solve, that's going to give me 10 equal to t. So then if I plug into the second equation, that gives me 3 minus 10 equals -7 plus 10. That's a -7 equaling a 3. They do not equal, therefore they don't meet. Yes? Now it says find the distance between the helicopters when t equals 10. I need to do what concept? That represents distance. I am going to need to do the magnitude. More specifically, it's asking me when t is equal to 10, so I need to actually find what first before I can do magnitude. I need to find the placement. I need to find that point where they are amongst this open space. So I'm going to plug 10 in for t into both equations, actually work it out to figure out where each plane or each helicopter is located. And then, let me go ahead and do that now. If I plug in 10, this becomes 11 plus 10, which is, then it becomes 10 minus, or 3 minus 10. And then negative 3 plus 40.
37.
For R1. Again, I'm just plugging in 10 for T. This becomes 1 plus 20. Negative 7 plus 10. 3. And then negative 2 plus 90.
88.
So this is their position of the helicopters after 10 seconds. I'm trying to find the distance between the two helicopters. So what do I need to do? I need to find the vector between the two, which means I need to do what? Subtract them. And then that vector, I do what? I find the magnitude of that. So then that'll be 0, 10, 51. Then the magnitude of that, which is 0 squared plus 10 squared plus 51 squared, which is
meters.
questions. Let's take a look at those two problems that you were doing on your own. Okay, so the initial position was T is 0, so that's the point 3, 1. So when it asked you for the initial position of the object, it is that position point, that vector 3, 1. Then you had to show the position of the object on a graph at the start, at 1 hour, and at 3 hours. And so let me actually clear this all off. Okay, so at the start, you were here, you were at that position of 3, 1. So you should have had an X and Y axis somewhere on your graph. You should have had a point at 3, 1. After 1 hour, that means you had to plug in 1 into your equation. You found that you were at 1, 4. So again, you put a point at 1, 4. And then after 3 hours, you were at negative 3, 10. So you should have had a point in those 3 places on your graph. Hopefully you labeled X and Y, and you had those points there. Did you need to include the vectors? Not necessarily, but they all did originally, come from the origin. They're all position vectors, essentially. Then define the velocity, okay? Velocity is that vector, that direction vector, so that's negative 2, 3. And then you had to find the speed of it, which I think I accidentally, no, it's over there. Speed is the magnitude, square root of 13 kilometers per hour, or whatever decimal approximation that is. Questions?
For the velocity, what did you do for velocity?
It's nothing but that direction vector of negative 2, 3. So when you looked at your equation, that vector that was attached to that parameter of t, that is your velocity vector. It basically means that your object from its original starting, it's moving 2 kilometers west and 3 kilometers north. And as you can see, that's exactly what it's doing here. It's moving 1, 2, back to the west direction, and then 1, 2, 3 in the north direction. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Questions on this? This was the original question at the bottom. Now, if you look at that second question, okay, that second question, it gave you the speed and told you the direction of the plane. And the first question asked you to find the position vector R of the plane T hours after midday. Okay? In other words, actually to write the equation. Alright? Then it gave you all this other information about the displacement 1 kilometer due east, due north, and then the altitude, which of course represents the height of the plane. Okay, how high the plane is. What it was, before I show you the answers, what was the position vector when it first starts for that problem? It says at 12 o'clock midday, a plane A passes over the vicinity of the airport at a height of 12 kilometers. You have, okay, so it asks you to write the equation after midday. So midday is basically our starting point. So when that plane is over the airport, how far is it east? 0. How far is it north? It's 0. How high is it? 12. So your vector, your starting vector is 0, 0, 12 because it's positioned right over the airport and the height of it above the airport is 12. Okay? But you haven't gone forward, you haven't made a turn, you haven't continued to elevate any, you are right there over the airport. That is where that plane starts. But then that means from there it's going to continue to travel, right? It says that it travels at a speed of 800 kilometers per hour and the direction of the plane is heading 430. How can I get this vector right here? When you're given a speed of 800 and then a vector, a direction vector of 430. What concept that we talked about in vectors so far that incorporates some number value and a vector? What does that 800 represent? That magnitude, right? So I have a magnitude and I have a vector. Is there a concept that we talked about with vectors that involves a magnitude and a vector?
I believe the answer is yes.
The answer is yes. The answer very much is yes. Go ahead. Yeah. Can you read out to me? Times the scalar, yes. It was m times your vector divided by the magnitude of your vector. This was the formula that we had talked about. That was the formula to find a vector parallel to a given vector, I think? No. No.
Mm-hmm. Yeah.
Yes. Something along those lines.
Yep.
Okay. Your magnitude is what in this problem? 800. Okay, you have to multiply that 800 by that vector of 430 divided by its magnitude. What's its magnitude? Be 4 squared plus 3 squared plus 0 squared. This should be 4 squared plus 3 squared. 5. So I basically have 800 times, essentially 1/5, times that vector. So this becomes 800 times 4/5, 3/5, and 0. Yep, because you multiply the magnitude to that vector. That's what the fraction represents. So what's 800 times 4/5?
640.
640. What's 800 times 3/5?
480.
480. And the last one's easy. That's just
No one.
nothing. That right there represents the vector, the position vector R, T hours after midday. It's not going to randomly give you the speed of this plane and the direction which it's heading. You've got to be able to incorporate those pieces. Okay? So with that being said, that is what part A represents. That is this first part up here. We just did that. Then here's B and C, because of course you need that in order to answer B and C. B was asking how far they were, the position after 1 hour, so you just plug 1 into that equation. That's how you get 640, 480, and 12. And then it's asking you if there's another plane with a velocity vector of negative 300, negative 400, and 0, and a location given to you there. Remember, velocity vector basically represents the vector that's attached to the parameter. Is it in danger of colliding? That means you're setting up your equations and solving.
How did you use the 800 in the equation again?
800, that's your scalar, that's your magnitude. So it gets multiplied to essentially the unit vector. That's what vector u over the magnitude of vector u is.